In the vast silence of space, a red world shines in the distance, a beacon of mystery waiting to be unveiled. As the camera closes in, the planet Mars glows brighter, calling humanity toward its secrets. Since 2021, NASA's Perseverance rover has been exploring this alien land, searching for traces of ancient life. Rolling across rugged Martian terrain, the rover collects precious samples from sites once shaped by water. In July 2024, Perseverance reached a place known as Bright Angel at the edge of an ancient river valley. This valley may once have flowed with water, billions of years ago, carrying the potential for life. The rover encountered a strange rock named Chiava Falls, unlike anything seen before. Its surface was covered in unusual, leopard-like spots, raising questions among scientists back on Earth. Using onboard instruments, Perseverance revealed the rock contained rare minerals never seen on Mars before. Among them were greygite and vivianite, minerals on Earth often linked to microbial activity. Could these patterns be the fingerprints of ancient Martian microbes that once thrived here? The possibility electrified the scientific community. Life on Mars was no longer just speculation. Inside the rock, layers of clay appeared, clays known on Earth to preserve microscopic life. And surprisingly, these rocks were younger than expected, suggesting life may have survived more recently. NASA declared, "This is the strongest evidence yet that life once existed on Mars." Still, caution remains. Chemical reactions alone might explain these findings. More proof is needed. The ultimate test lies in bringing these samples back to Earth for advanced analysis. But the Mars sample return mission faces staggering costs, over $11 billion. Recently, U.S. leaders signaled plans to cut the program, shifting funds toward crewed missions instead. This decision could change not only science, but also the global balance of power in space. Today, a new space race is underway, with the United States and China competing for dominance. Unlike the Cold War, this race isn't just about pride, it's about controlling the future of humanity. Both nations now set their sights on the moon, not as explorers, but as settlers. The goal, to establish permanent bases that can harness its rare and valuable resources. One of these resources is helium-3, a potential fuel for revolutionary fusion reactors. Whoever controls it may power the industries of tomorrow and reshape the world's economy. In America, NASA's Artemis program plans to return astronauts to the moon by 2027. Their hopes rest on SpaceX's giant Starship, a vessel still facing critical technical hurdles. Meanwhile, China advances steadily, developing its Long March 10 rocket and Lanhua lander. They aim to land takenauts on the moon before 2030. A bold challenge to U.S. leadership. China's Chang'e 7 and Chang'e 8 missions are already preparing the way. They will search for lunar ice and test building habitats directly from the moon's soil. Robotic builders are envisioned to 3D print entire lunar bases, using nothing but dust and rock. Layer by layer, machines construct shelters where humans may one day live and thrive. In contrast, America's delays in Artemis raise alarms within the space community. Each setback risks ceding the symbolic first step on the moon to China. Inside futuristic habitats, Chinese astronauts train and simulate life on the lunar surface. From their base, they will gaze at Earth, knowing history is tilting in their favor. Beyond the moon, alliances are forming. China and Russia strengthen their cooperation in space. Together, they sign bold treaties, laying the foundation for joint lunar colonies. The race is not just for prestige, it's for lunar water ice, the most vital resource of all. This ice can sustain human life and even be turned into rocket fuel for deeper exploration. From this frozen treasure, future rockets may be fueled, transforming the moon into a launch hub. Pipes and tanks fill with liquid hydrogen and oxygen, the building blocks of interplanetary travel. Soon, new launch pads on the moon will send spacecraft outward, beyond Earth's grasp. Inside the cabin, astronauts strap in, their visors glowing with reflections of a new frontier. With thunderous power, rockets lift from the lunar surface, casting plumes of dust skyward. As they ascend, the moon shrinks below, and Earth shines like a jewel ahead. Back on Earth, nations gather in massive conferences to debate the future of space. Maps of the moon and Mars glow in holograms, while leaders argue who will lead humanity. From orbit, Earth glitters with webs of light, a reminder of both unity and division. Satellites hum silently above, carrying the signals of a connected but contested world. Yet orbit is no longer only scientific. Military satellites prepare for dominance. On screens, alerts flash. Orbital control is no longer a dream, but a strategy. Meanwhile, in hidden labs, scientists study glowing Martian rocks under futuristic microscopes. Inside one stone, a faint glow hints at the greatest question of all: did life exist beyond Earth? Teams of researchers project holograms of Mars, zooming in on Bright Angel Crater. There, the mineral traces suggest microbes may once have thrived in Martian waters. Futuristic cities rise on Earth, their skylines crowned by spaceports and launch towers. Cargo pods climb into orbit on space elevators, bridging Earth and the stars. On the Moon, astronauts raise an international flag above their new colony. In its reflection, Earth shines bright, a symbol of unity or rivalry yet to come. Far away, domes glow beneath the Martian sky, the first human colony on the red planet. Inside, plants grow under artificial lights, life transplanted from Earth to Mars. Now, Earth, Moon, and Mars align in the heavens, marking humanity's next great leap. The new space race has begun, and its outcome will shape the destiny of our species.